Hello. The problem is count subarrays with some x. In this video, we'll first understand the problem and next go on to the approaches and see their time complexities and choose an optimal approach. First, let's understand the problem. We'll get an array and also a target sum x. We have to find the contiguous subarrays whose sum is equal to the target. Let's take an example. In this example, this is the array and this is the target sum. The target sum is 5. We can see here that the subarrays 2, 3 sum is 5 and the subarray 5 is itself a target sum. So we have total of 2 subarrays whose sum is equal to the target. This is the problem. So let's see what are the approaches. First approach that gets into our mind is the brute force approach. First we'll generate all the subarrays, then calculate the sum for each subarray and compare it with the target. If the target if it equals to the target, we'll increment the counter. So let's see this approach logically. Let's take an example and see this approach logically. This is the array and the target is 5. We'll start from index 0 and go on generating the subarrays with the same index 1, 1, 2, 1, 2, 3 and so on. We'll generate the sum for each subarray and compare it with the target. Here none of the sums are equal to the target, so we didn't get an subarray. Then we'll move on to the next index. In the next index, we found a subarray whose sum is equal to the target, so we'll increment the counter to 1. Then we will go on to the next index. Here also no subarray is found, and then the next index, and then the next index, and the last index having 5 as the subarray, having element 5 is itself a target. So we found another subarray that equals to the target. So the total we found 2 matches. Let's build a code. Okay. First, we'll use of 3 loops. First loop is for the starting index, and the second loop is to go on from the starting index to the ending index by generating the subarrays with the starting index, and the next loop is to calculate the sum of the each subarray generated. We'll initialize a counter with 0 outside the loop and increase the counter whenever the sum is equal to the target. This is the code, and its time complexity is O of n cube, as it have 3 loops, as there are 3 nested loops, and this makes it extremely slow while dealing with larger arrays, and it only uses constant extra space. So this approach can be optimized, and let's see the optimized approach. Optimized brute force logic. Instead of generating and calculating the sum of each subarray, we can add the element which is adding to the previous subarray to the sum. So let's see it with an example. This is the array and this is the target sum, that is 5. We'll start with index 0 as usual and we'll go on until the end index. Rather than generating the sum for every index, for every subarray, we can just add the element which is adding to the previous subarray to the sum. So in the first subarray the sum is 1. In the second subarray the sum will be 3. But rather than calculating the sum by again initializing it to 0, we'll just add the element which is adding, that is 2, to the sum. So 1 plus 2 is 3. So it goes on until the end, and we'll compare every time the sum with the target, and if a match is found, we'll increment the counter. Let's build a code for it. again it's as usual, we'll initialize a counter variable with 0, and this time we only use two loops. One is for the starting index and another is for the ending index. We didn't use third loop because we are adding the new element directly to the sum. So we don't need a third loop. And its time, and let's see its time complexity. Its time complexity is O of n cube, and its space complexity is O of 1, which is far better than the previous one. Though the time complexity is reduced, it still takes it still takes large time for the larger arrays. So there are two more approaches to get the answer, and they will be discussed by my teammate.
Hi, I am Ravichandrika. I am here to tell about count sum of subarrays with sum x using hash map and prefix approach. Here the core idea using prefix sum has you traverse the array. If current prefix minus x exists, a valid subarray exists, we use hash map to store prefix sum frequency. Here we take an array of length Here we take an array of length 5 with elements 1, 2, 3, -2 and 5, target sum 5. At first we map 0 to 1 and initialize prefix sum to 0. As we move, prefix sum is 6. Check 6 minus 5 is equal to 1, which is it means a valid subarray exists. And prefix sum is 9. Check 9 minus 5 is equal to 4, which exists in the hash map. So prefix sum 9 and check 9 minus 5 is equal to 1, which is in hash map. So we increment the frequency and the final count is equal to 2. Here the implementation map 0 to 1 handles subarrays starting at index 0. At each step, update prefix sum and check whether prefix sum minus x exists in the hash map. If exists, increase the count value. Otherwise, store current prefix sum in map. Here is the implementation map 0 to 1 handles subarrays starting at index 0. At each step, update prefix sum and check whether prefix sum minus x exists in the hash map. If exists, increase the count value, otherwise store prefix sum in map. Here the time complexity hash map allows order of 1 lookups break it is very fast. Phase complexity is order of n because hash map stores prefix sum up to n values. This is the best general approach solution works with negative numbers. And here the another approach is sliding window approach. Before discussing about the sliding window, we should also require to know about the limitation of sliding window approach. Sliding window approach works only for non-negative arrays. Here we take an example of 2, 3, 2, 5. Here window expansion and contraction is happen. If sum is less than target, expansion of window takes place. Else sum is greater than target, contraction of window takes place. For the windows 2, 3 and 3, 2 are the valid windows to the count and the count becomes 2. Here the window moves effectively without backtracking. Now the implementation of sliding window. Here we take two pointers, right pointer and left pointer. We initialize both pointers with 0. Right pointer expands with window and left pointer shrinks window, and sum maintained dynamically. When it comes to the time complexity, each element is visited at most twice by right pointer and once by left pointer. So the time complexity in this sliding window approach is order of n. When it comes to the place complexity is order of 1. Only two variables are taken regardless of the input size. And the limitation of sliding window is it only works for the non-negative arrays. Thank you.